Hello everyone, this is Aditya and today we are going to discuss rotation in one go. But before that, please do like, share, subscribe my channel and please support this video. Now let's start the lecture. And yeah, I'll be teaching rotation in a different way, like everyone teach first theory then discuss questions. But I will be directly starting with the question and I will explain theory in that only, right? So now let's start. So this is a nice question. It came in IAT 2025, that is Eisner Aptitude Test 2025, right? So it was a nice question from physics, from rotation. So I thought to discuss whole chapter using this problem, right? So before reading this problem, let me introduce some of the terms, right? So there's something called moment of inertia. Moment of inertia. It is defined as I, which is equal to mr square, right? Okay. Basically, here r is radius of gyration. Don't worry, we will discuss everything. Just for now, remember these concepts, these terms, right? So basically, in linear motion, we had the inertia in terms of mass. And in this case, when we are dealing with rotatory motion, rotation, here the moment of inertia, or that is inertia of rotation, will be this moment of inertia, that is I, right? Understood? So basically, that is the difference between linear and rotatory motion. Here we are defining it like mr square. There we had mass itself as inertia, right? Okay. So this I will be very much helpful in calculation of many concepts in rotation. So this is the basic, this is the backbone of this whole chapter, right? So you should remember this. Okay. So let's discuss moment of inertia for some famous terms. And yeah, suppose if you have a disk, I mean suppose if you have a continuous body, this is for a discrete body. And suppose if you have a continuous body, then in that case I will be equal to r square dm, right? You have to integrate this, okay? Correct? Okay. So let's discuss some of the famous figure which we come across in this chapter, in which we should know their moment of inertia. Suppose first is your ring. Suppose you have a ring. Let me draw it slanted like this. This is the ring. Suppose you have a disc. Suppose you have a sphere, a hollow sphere, and you have a solid sphere. Correct. Now you should remember one thing, that the moment of inertia is dependent upon the axis you choose, axis of rotation which you choose. For example, in all these four examples, we are dealing with the center of these figure. This is the center of this sphere, this is the center of this sphere, right? And we'll consider a normal drawn, okay? Correct? So basically it is perpendicular to the surface, right? Basically that is meant by normal, right? And suppose it is rotating, okay? Correct? So what linear, I mean, so what will be the moment of inertia in this case? Well, we define moment of inertia as I is equal to mr square for a ring, and for disk we define it as mr square by 2, and for sphere we define as 2 by 3 mr square, and for solid sphere we define as 2 by 5 mr square. Correct? Okay. And of course, all these results can be derived using this continuous moment of inertia formula. But I don't think so that we should discuss it right now. We can discuss it in some other video, right? So currently we are just dealing with this, right? Okay. So I defined here something called radius of gyration. So let's study that also over here, right? Okay. So basically radius of gyration is the radius of that ring which has an equivalent mass equal to any of the diagrams which we are dealing, right? Such that the moment of inertia in both the cases is same. What do I mean is that, suppose I define radius of gyration as r, small r, right? So we will consider a ring like this. So what is the moment of inertia of a ring? It is m r square, if you assume its radius as r, right? So it should be equal to this quantity mr square by 2. So we get r is equal to root r by root 2, right? So what is it telling us? It is telling that to make the moment of inertia of a ring equal to that of this disk of same mass, that is a ring and the disk has same mass. So for that, the radius of that ring must be equal to r by root 2, right? So of course it has a mass and radius r, it has a mass and radius, it has also mass, radius, mass and radius, right? Correct? Okay. So basically it is the ring equivalent of any figure, right? For moment of inertia, right? If we talk in a general sense, right? So for this, if you want to calculate mr square is equal to 2 by 3 mr square, you just cancel mass and you get the value of r in this case also, right? For ring itself, of course, for ring it will be r is equal to capital R, right? Correct. Okay. Now I said something that the moment of inertia is dependent upon the axis which you choose, right? So how we define it? Let's see. So there's something called parallel axis theorem and perpendicular axis theorem. So let's discuss them so it will be easy to discuss it. Parallel axis theorem. So suppose you have a ring over here, right? And this is its center of mass, correct? Of course, a norm is passing through its center of mass. Of course, center and center of mass will coincide for this case, right? So it states that suppose the moment of inertia about center of mass is suppose I naught, right? This is your center of mass I naught, right? Correct. And if you assume any point, any other axis parallel to this, of course they both should be parallel, these both axes should be parallel to each other, right? At a distance d, then moment of inertia about that axis if it is rotated about this axis, right? Understanding or not? Let me tell you an example. Suppose this is the marker and I am rotating it from its center, right? So this is the case, right? Like this. Now it was passing earlier through its center of mass. Now I changed the axis and I made the axis like this. Now I'm rotating like this, right? Understanding or not? So how will we calculate the moment of inertia about this axis, right? So that is how what we mean, right? So earlier it was rotating about its center of mass, right? Axis passing through center of mass. Now it is rotating about this point, right? Suppose point O, right? So moment of inertia about the axis passing through point O is given as, suppose it is I over here. So I is equal to I naught plus, suppose the mass of this disk is m, plus m d square, right? This is the parallel axis theorem, right? So from this you can say, suppose this is a disk, okay? So we had calculated that about its center of mass, it was having mr square by 2 as its moment of inertia, right? I naught. Suppose now it starts rotating about its one of the endpoints, right? So what is its distance? It will be r, correct? And it has a mass m. Hence, moment of inertia about this point will be equal to I naught plus m d square. So it is equal to mr square by 2 plus mr square, which is equal to 3 by 2 mr square, correct? Correct or not? Correct? Okay. Now there's something called perpendicular axis theorem. Let's discuss that also. And it is valid for 2D plus 3D figure both. Correct? Correct? Okay. So let's discuss that also. Perpendicular axis theorem, right? Okay. So let's assume again this figure, right? So suppose let me define, suppose this is your z axis, this is the moment of inertia about z axis, okay? Let's assume it is about z axis. So the moment of inertia about ix and iy over here, right? Let me draw it. So it should be iy and it should be ixy, because I cross j should be equal to k vector, right? That is why. So it is valid for planar object, that is 2D only, right? So it states that Ix plus Iy should be equal to Iz, right? Okay, correct. So this is how you find the moment of inertia in such cases. So for example, if I take the example of a disk again, so moment of inertia about this is equal to mr square by 2, right? Correct. Okay. Now if I ask you moment of inertia about Iy and Ix, suppose, right? Now since disk is symmetric, which implies that Ix will be equal to Iy, right? Since it's symmetric, right? Okay. Hence Ix plus Iy is equal to Iz. Hence 2Ix is equal to mr square by 2. So Ix is equal to Iy is equal to mr square by 4. Correct? Correct. Okay. So now here comes a very famous question which comes in JEE mains also and sometimes in NEET also, I guess. And it is a favorite question actually. So let's discuss that also. So assume this is a disk and its axis is like this. This is not perpendicular to it. It is like this. This is your disk viewed from upward. So this is your axis like this. Understanding or not? Are you understanding? Well, if this is your disk, then the axis is going like this, not like this. It is going like this. Okay, correct. So this is the axis passing through center of mass, right? So of course its value will be I naught is equal to mr square by 2. Correct? Correct or not? Correct. Okay. Now let me draw it slightly slanted so that you can understand it. This is going like this, okay? This is a top view, right? This is a side view. Now to solve for this axis, you need a slanted axis over here, right? Like this. Correct or not? Correct? This is your Ix and this is your Iy, correct? X cross Y is equal to Z. Yeah, correct. So we had calculated that Ix was equal to mr square by 4, correct? Mr square by 4, correct? Okay. And which was equal to Iy also. So basically this is your Iy. Okay. So it was equal to Iy is equal to mr square by 4, correct? And this is the distance r, right? Okay. Hence we get I is equal to what? mr square by 4 plus mr square, which is equal to 5 by 4 mr square, right? This is the parallel axis theorem. This is the perpendicular axis theorem. So in this we have to apply two theorem, right? That is perpendicular and parallel axis both, right? And it is really helpful in many calculations, right? So of course it is like 2D and I'm trying to draw a 3D figure over here. That's why it's not that much clear. The diagram is not that much clear. But the best I can explain is like this is. So suppose this is the disk and the axis passing like this horizontally, not vertically. This is the vertical case. So for passing normally to the center of mass, it passes like this, right? So it is not going like this. It is going like this, right? Over here. So basically this was for center of mass. Now we applied the perpendicular axis theorem. So we got the moment of inertia about this axis also. And now this axis and this axis are parallel, right? So we can apply what? Parallel axis theorem, right? This is the concept which I applied over here, right? And of course I named it like Ix and Iy. It's on you that you assume it I1, I2 or whatever be the case, right? Since we were not given that what is the convention over here, so I just assume it Ix and Iy, right? It is not necessary. If you are confused, then you can use I1 and I2 also. That is also correct, right? Okay. So let's see the next concept. Now, when you were solving the equations of motion for a linear motion, basically, you had this expression v is equal to u plus at and s is equal to ut plus half at square and v square is equal to u square plus 2as, correct? Okay. So when you go to rotation, then you will study that it is equal to, that is we are studying only, then you will find that omega is equal to omega naught plus alpha t, where alpha is the angular acceleration, right? And this is the angular velocity. This is the angular displacement is equal to omega naught t plus half alpha t square, and omega square is equal to omega naught square plus 2 alpha theta. Correct? Correct or not? Correct? Okay. So this is linear and this is rotation, right? Okay. So many times questions are asked from this also, right? Which you should remember, right? Of course, you can derive this also as we derived this one. You can also think it in rotation terms and you can solve for it, right? Correct. Okay, let's do a question for finding the moment of inertia of a rod. Okay, suppose this is our axis, right? And it is rotating. This is our rod of uniform mass density, that is its mass by length is equal to constant, which is equal to lambda. Okay, and it is rotating in whatever direction, we don't care about it. Okay, these are axis of rotation. Correct? Okay, and suppose it has a length L. Correct? Okay, so how we find the moment of inertia of this rod? Why can't we directly use mr square? Because we don't know it, because it is a continuous mass, right? Of course, ring, disc, and every other figure which we studied were continuous mass, but they were standard, right? We knew how to find them. We actually knew its value, and of course we can find that also, but that is not required right now, right? If you want, I will make a separate video for that. Okay, so let's find this. So how we will find it? We know that I is equal to integral r square dm. Correct? Of course you have to take limits also, but don't worry about it. Okay, so now mass is equal to, well, suppose you take a small mass, this dm, let's assume dm, and its length is dx. Let's assume it is dx. Okay, at a distance x, right? So we can write it as x square dm. Correct? Okay, now notice that m by l must be equal to what? That is, since the mass density is constant, which means that lambda is equal to dm by dx. Correct? Correct or not? Correct? Okay, hence dm is equal to lambda dx. Correct? Correct? And what is the value of lambda? It is equal to m by l, where m is the complete mass of this rod and l is the complete length of this rod. Okay, so dm is equal to m by l dx. Correct? Correct or not? Right? Okay. And yeah, in question they can give lambda as a different function also. Maybe it is dependent upon some of the variables over here, right? So in that case also you will apply this only. Just in that case you will put lambda according to the given values. Okay, simple. Okay, so we get x square into m by l dx, right? Now how we have to integrate it? Well, it's going from x is equal to 0 to x is equal to l, so it is going from 0 to l. Correct? Correct? Simple. Okay, so we get m by l multiplied by the quantity 0 to l x square dx. Correct? Simple. Simple or not? Simple, right? M by l into l, that is x cube by 3. Limits are from 0 to l, so we get m l square by 3. So the moment of inertia of this rod about this axis is what? Is equal to ml square by 3, right? Correct? Okay. Now what if I ask you that what is the moment of inertia of this rod about the axis passing through its center, right? So in this case also you will assume a dx length mass, I mean a mass dm and dx over here, and this is x, right? Again, but in this case you will integrate it like this: negative l by 2 to l by 2. Why? Because if we assume this as our 0 comma 0, right? So this is negative, this is negative value, this has negative value, I mean, and this is positive value, into the quantity x square m by l dx. So we get basically m by l multiplied by the quantity x cube by 3, and it goes from negative l by 2 to l by 2. Correct? So we get m by l multiplied by the quantity L cube by, we can take 3 common, correct? So we get L cube by 8 plus L cube by 8. Why? Because here it is negative, so negative and negative will become positive. So we get L cube by 4, so we get ML square by 12 in this case, if it is passing through center of this rod, correct? Okay. So this is the basics of rotation which you should know, right? And of course there are some other things also, like, yeah, kinetic energy is equal to half I omega square, which you should know, right? There are some other topics which are there in this chapter which I don't think that I should discuss right now, because you will get confused, right? That is what I'm thinking, is that when I will make other one shots, in that I will cover when I will feel it is required, right? Or we'll cover it in some sort of questions which I will upload, right? Okay. So now let's do this problem. Okay, let's do it. And of course you can check my video on mechanics one shot. In that I have covered rotation also, and in that there are many good questions also. And I covered JEE Advanced 2016 question of rotation, which everyone said that is the toughest question of physics in history, right? So I discussed that also. You can check that also, right? So I've taught that concept also, that question also. So if you want to become best in rotation, you can check that video, right? Those two videos, right? So it will help you to gain lots of confidence, and it will help you to gain lots of enthusiasm towards rotation, and your basics will boost a lot. So do check them out. Okay, so let's see this question. A circular disk of mass m and radius r. So you are given a circular radius, circular disk of mass m and radius r is rotating clockwise. So it is rotating clockwise with uniform angular velocity omega, right? Okay. Now if it is rotating clockwise, then what is the direction of angular velocity? It is given like this. Basically, if the body is going like this, then you keep, this is the direction of velocity and this is radius, right? So you just keep your hand over here, right? Right hand, and you place your thumb like this. And if the direction of velocity is along this, then you just curl your hand like this, right? So this thumb is given the direction of omega, right? So omega is going like this in downward direction, right? And suppose if the velocity was along this axis, then it will be like this. It will come outwards, right? But in this case, it's going inwards, right? Like this, along this axis, right? Axis of rotation, basically, right? So about an axis pointing through center normal to the disk, that is this only, at the center of mass. At time t is equal to 0, a torque is applied along the same axis to oppose the rotation of disk. What is the angular displacement measured from t is equal to 0 in clockwise direction, okay, that disk attains before it starts counterclockwise motion, right? So basically currently the disk is rotating in clockwise direction. So we applied a torque to oppose its motion. So of course in linear motion, to stop a motion we applied force, or to give the motion we applied force. Here to increase the omega or decrease the omega, we applied torque, right? That's the difference between linear and rotation, right? Okay. So in this we are applying a torque to oppose its motion. So basically if it is moving clockwise, so of course if you apply torque, then there will come a point that its angular velocity becomes 0, and if you apply more torque, it will start rotating in different direction, that is in counterclockwise direction. So basically we are asked that disk attains before it starts rotating counterclockwise. So basically we have to check at when the angular velocity becomes equal to 0, correct? Correct or not? Correct, yeah. Hence, what is the torque applied? Torque is equal to what? I alpha, right? Of course, I should have discussed it before, but I think so that it is the right time to discuss it. So torque is given as I times alpha, right? Alpha is what? Angular acceleration, right? And I is the moment of inertia, right? Okay. So this is torque, right? Hence we can say tau is equal to I into Of course, what is the I in this case? It is mr square by 2 alpha. Correct? Correct. Now, what is the direction of alpha? Well, if omega is in this direction, so alpha has to be in this direction. Why? Because it is opposing its motion, right? So alpha is creating a motion counterclockwise and omega is creating a motion in clockwise, right? So that is why. Hence, we get alpha is equal to negative 2t by mr square. Why negative sign? Because it is opposing the motion, right? So that is why I used a negative sign over here, right? Now we need to find the angular displacement. So what is the formula for angular displacement? We had two formulae, that actually three formulae. Omega is equal to omega naught plus alpha t, theta is equal to omega naught t plus half alpha t square, and omega square is equal to omega naught square plus 2 alpha theta, right? So now which one we have to use? Think and answer. Well, we can use this one. It will be very easy if we use this one, right? Correct. But let's use this and this, so it will be fun, right? If you use this one, you can directly get the answer, right? So it won't be that much fun. So let's apply these two, right? Let's calculate time also. So we want omega to be equal to 0, correct? So omega naught minus 2t by mr square multiplied by t is equal to 0. So t is equal to mr square omega naught by 2t, correct? It is simple maths, right? Now theta is equal to omega naught t plus half alpha t square, correct? So omega naught into this quantity mr square by 2t into omega naught minus half into 2t by mr square into square of time, which is equal to m square r to the power 4, m square r to the power 4 omega naught to the power 2 divided by 4t square, correct? Okay, so it will become 4t, right? It will become mr square, and so from this you get theta is equal to mr square omega naught square by 4t, and that's the answer. You solve it. When you solve it, you will see that you are getting this only, right? So this is the angular displacement which the body makes before it comes to rest or before it starts rotating in counterclockwise direction, right? Okay. So this was all about rotation, I guess. And of course, there are some more terms which are related in this, which we can discuss later, right? Not right now. And of course, if you want to find the kinetic energy in this case, what it will be? It will be half I omega square. So let's assume we are finding the kinetic energy initially. So we get half into mr square by 2 into omega naught square. So it is mr square omega naught square by 4, right? Correct? Okay. Correct or not? Correct? Easy, simple? Right. Okay. So with this, we come to an end of this lecture. If you did enjoy this video, then please do like, share, subscribe my channel, and we support this video. Bye bye. Take care. And if you have any doubt, then please do let me know in the comment section. I will take that doubt and discuss it in some other video, right? Till then, bye bye. Take care and all the best.